name is Christopher Harrison. I'm a senior developer advocate at GitHub, and here to talk about shifting left the right way, which is a fantastic little pun, or at the very least in my head, it's a fantastic little pun. Shift left has really been the mantra of security for the dawn of time. And for those who aren't familiar with this concept, shift left simply means that we are going to try and catch security flaws as early as possible. That the great part about catching a security flaw, say, before it's written or before it gets checked into main, and certainly before it gets deployed, is that the earlier that we can catch it, the easier it is to resolve, and the less chance, of course, that something is going to wind up going catastrophically wrong. Because should there be a data breach, now catastrophe has struck. But we've been screaming shift left, shift left, shift left, shift left for about as long as I can remember. And unfortunately, it really in a lot of ways hasn't been successful. That when we take a look at the amount of tech debt that exists, it's pretty remarkable. So 70%, or 71 if you want to round up, percent of organizations have security debt defined as a flaw that's been there for longer than a year that has not yet been changed. And on top of that, nearly 90% of that security debt exists in first-party code that a lot of times when we're thinking about, hey, I've got a potential flaw, it must have been somebody else's code, it must have been somebody else that wrote it, it must be a package that I'm using that's causing that flaw, when in reality, it is our code that's doing it. And on top of that, one of the other big things that we're going to notice is that 47% of the flaws that exist that aren't yet tech debt, that aren't yet a year old, are going to become tech debt. So we are not getting ahead of things. We are not making headway. So let's get into it then. Let's talk about how we currently do things. Let's talk about the landscape, and let's talk about why things fail in that environment. Then we'll take a look at how we should be doing things, a couple of little updates that we can make to the model, and also how we can better work with the humans that are involved in this process. And then finally, we'll bring it all together by taking a look at how we put all of this into action. So let's talk about how we currently do things. And when we think about shift left, we're of course never going to get further left than the developer. So let's make the developer a security professional. And this, sadly, does not work. And the primary reason for that is because of the fact that developers are developers. They're not security flaws. I spent many years as a tech trainer. And one of the things that I would always try to do is make sure that as I'm teaching, for example, database access, the concept of SQL injection. And periodically, I would get a student in my class who would go, everybody knows this. Nobody is writing code that's still incorporating SQL injection. We've got one slide, 2 slides, and 3 slides that demonstrate that those classic security flaws, things like cross-site scripting, SQL injection, buffer overflows, that all of those flaws are still continually in the top 10. I mean, I suppose on some degree it's kind of nice that we're sticking to the classics, I guess. But yeah, so we have a real problem here because again, our developers are not security experts. Okay, well, then why is that? And just a real quick, again, bad things. So why is this? Why does this still happen? And the number one reason is that developers are taught insecure methods. One of my absolute favorite comics is the XKCD 10,000 comic, which if you've not seen that, just don't do it here. But at some point, go out and Google XKCD 10,000. And the basic premise is that in order for something to be common knowledge, theoretically 10,000 people per day need to learn that piece of information. So in order for all developers to know about SQL injection, we'll just kind of keep using that as the example here. In order for every developer to know that, developers need to continue to be taught that. Well, when a developer goes out to learn a new skill, quite frequently, they're not taught the correct way. And again, I'm saying this as somebody who's been a tech trainer. I'm saying this as somebody who has taught students. I'm saying this as somebody who's uttered the phrase, "You wouldn't do this in production." If you head out to the interwebs and you do a search for create a website with a username and a password, storing that in the database or some variation thereof, you will see articles that will show you how to store that password. Sometimes they'll actually use one-way hashing. They're not going to solve the password, but at least they're using hashing. Some of it will use encryption, and some of it will actually show you a demo of storing the username and password in clear text, which generally speaking, not a good idea to store passwords in clear text. I apologize. The cold, I'm not sick. The cold just makes my nose run like crazy, so I apologize. So in all of those scenarios, we're teaching developers quite frequently the wrong thing. So they need to do something, they go out to the interwebs, and that's what they're being taught. That is our first big problem. The second is security training isn't effective. That here's what we do, is we take our developers, we every year, there's a knowing laugh right here, we send them out to some class, we bore them with the OWASP top 10, and then we send them back to their keyboards to start writing code again. And none of what they've learned, or very little of what they've learned, is directly applicable to what it is that they're doing, that it's only ever going to be meaningful to them if it's on their code. And that becomes a little bit of a problem. Because when I'm writing code as a developer, I want to see a change that I've made. Like if I go to add on a new feature and I write a unit test, I'm going to write my unit test, I'm going to run that test, I'm going to see that it fails, I'm going to go out, I'm going to make the change, I'm going to run that test again, I'm going to see green. I'm going to see an active change. If I write a SQL query that doesn't accidentally incorporate a SQL injection attack, what do I see? I don't see anything. And so it's really difficult for developers to truly see the impact of writing secure code. And then finally, last but certainly not least, is the fact that well-meaning developers wind up taking shortcuts. I'm not going to ask anybody to raise their hands because I'm not going to call anybody out. But who in here, maybe who in here hasn't uttered the phrase, "I'll go back and fix this later"? We've all been there because we just need it to work right now. So we wind up taking that shortcut, we introduce the security flaw, and now we need to go back and fix it later, and later never comes. Okay, new idea. Let's hire security teams. So it's not as left necessarily as we would necessarily like, but at least now we've got dedicated professionals that are going to take a look at everything. That's great, right? Well, here's then what we wind up doing. So we got our developers over here, we got our security team over there. The first big problem that we're going to have with our security team is that they're going to be much smaller than our development team. That depending on the stats that you look at, it's somewhere around like 60 to 1, 60 to 1, which they're kind of outnumbered. On top of that, the other very big thing that we have is our developers don't talk to our security people, and our security people don't talk to our developers. And so what happens is our developers write the code, they'll throw it over the wall. I'm going to have a slide talking about that here in a minute. And then our security team will get involved and take a look at it. And with all of this lack of communication, for want of a better way to put it, it winds up creating a level of like distrust between these two teams. And what it winds up feeling like is that the developers are out there trying to introduce features, and the security team is just there to say no. I'm not saying that that's right. I'm not saying that that's fair. What I'm saying is that's absolutely the way that it feels. That we're not setting our security teams up for success here, that we're not getting them involved in the process early enough, and we're not getting our developers talking to our security teams to allow them to learn how to best do things. And so instead, we've got our normal DevOps pipeline here. We're writing our code, we're doing our integration, we're putting into the deployment pipeline, and then finally, we're going to start doing some security testing. And this is way too late in the process. Because first of all, again, just from a human standpoint, if all of a sudden I've gone through all of this and now I've gotten to production, I'm already celebrating, cool, features deployed, I'm done. And now all of a sudden it's thrown back at me. But on top of that, our security team is now going to feel an awful lot of pressure. Because we've reached that point of the deployment process. And they're going to feel a lot of pressure just to hit the button and let it go. Because now they have to decide, okay, is this worth it? Is this worth going, hey, we've got a flaw here, let's go back to the very beginning. So we need to be doing something further left than all the way over there. All right, so we can't just rely on our developers, we can't just rely on security teams that are coming in late in the process. We've kind of talked about all of that. So here's a better idea. Let's throw money at the problem. That'll solve everything, right? And the problem, of course, is when we start throwing in brand new tools, a lot of times what we do is we introduce complexity. Because now this is something else for my developers to do. That they need to run this external tool, they need to perform this additional task. That now I'm asking them to inconvenience themselves. And so, put simply, security at the expense of usability comes at the expense of security. That if I'm making things complex, then things aren't going to happen. And on top of that, one of the mantras that I really go to is buying a treadmill doesn't make you a runner. Everybody has done something like this where they buy that brand new piece of exercise equipment thinking this is it, this is going to be the year, and it makes for a fantastic hanger. Just buying the tool doesn't actually change behavior. That we need to make sure that we're going to use the tool, we need to actually find the right tool for the job. Okay. By the way, yes, that is my treadmill. I would like to highlight I actually do use the treadmill that was staged. In any event, okay, so let's talk then a little bit about how we do things, but before we get into that, let's define a couple of terms here. Now, I'm going to make an assumption that everybody's probably familiar with DevOps and DevSecOps, but I still think it's important to just take a moment. So DevOps is a portmanteau. Such a fantastic word. It's a portmanteau, of course, of development and operations. And in a nutshell, what we're trying to do is get the operations team involved in the development process and get the developers involved in the operations process. So that way, again, it's not just simply developers writing a whole bunch of code, throwing it over the wall, and then leaving it up to our ops team to figure out how to deploy it. And more importantly, figure out how to fix things when something goes wrong. And vice versa, that our ops team is then going to be involved earlier, so that way they can help guide the developers through the process and make sure that whatever it is they're going to be building will deploy correctly. DevSecOps just simply brings security into that process. And when we think about DevOps and DevSecOps, there's a few areas of focus that I want to make sure that I highlight. And the first one is, let's assume best intent. If I have a developer that is pushing insecure code, they are not doing this maliciously. They are not doing this because they are trying to fight back. They are not doing this on purpose. They're doing it for a host of reasons. Maybe it's because they don't know any better. Maybe it's because they are taking a shortcut. I want to figure out why it is that they're doing it. But it's almost certainly not going to be because they are being malicious. So we want to keep that in mind, always assume best intent. We also want to keep in mind that we are a team. That my security professionals are security professionals. They're not developers. They might know a little bit about development, but they're certainly not developers, and vice versa. that my developers are developers, they're not security professionals. So I want to play to each other's strengths and make sure that we're setting everybody up for success. But I also, I'm going to go all the way back to this slide back here, want to make sure that we're on the same team here. I don't want my developers on the left side, security on the right side. Let's bring those people together and get everybody onto one team because we are a single team. In addition, we want to make sure that we're always reviewing the output and reviewing the process as well. That we want to be ruthless when we are reviewing code, not the coder. We're not reviewing the human, we're reviewing the output. We're reviewing the app. We're reviewing what it is that we have generated. And then finally, last but not least, is to automate all the things. That we want to streamline this process as much as possible. When we were talking previously about tools, the best tool in the world is the one that the developer doesn't have to do anything different to incorporate into their flow. That if I just simply make the PR and it runs, I'm good, because then there's nothing else that I need to think about. So how then do we do the thing? And the approach that we want to take is what's known as a Swiss cheese approach. I already see a couple of people looking at it and thinking, wait a minute, Swiss cheese, that's the one with the holes, right? Yeah, it is the one with the holes. But here's the thing, is that there is no individual layer when we're talking about DevSecOps that's going to catch everything. Something is going to wind up falling through the cracks. So what we want to do is put as many layers as possible so that there are no cracks. That's the concept of a Swiss cheese approach. Because if I take one piece of Swiss cheese, bunch of big holes. If I take 4 or 5 pieces of Swiss cheese and I now put them on top of one another, now this is going to have the holes here, this is going to have a hole here. This analogy is kind of hard to indicate like this, but go with me. Think about Swiss cheese, okay? Lay them on top of one another. And eventually what we're going to wind up having is a lack of cracks to be able to fall through. So we want to make sure that we are looking at multiple layers. And we can really break this down into kind of 3 main layers, which is going to be the code that we write, the code that we use, and of course, the secrets that we're going to need inside of our app to perform certain operations. So let's talk first of all about the code that we write. And let's take a moment here for our poor overloaded devs. Because what they have is a limitless set of feature requests and a limited amount of time with countless languages and frameworks in an ever-changing landscape, and code that needs to be of high quality and high performance, deployable to a complex landscape of services, microservices, and cloud providers. Oh, and by the way, it needs to be secure. They're overloaded. So we want to make sure that we're able to support them as best as we possibly can and where they are at. Because again, good DevOps, let's have a good process, key to good DevSecOps. So how do we support our developers? Well, number one is, while yes, we should teach them certain vulnerabilities, we should make sure that they are aware of the most common vulnerabilities specific to the code that they are writing, the environments in which they're working. But I also want to teach them code smells. And if you're not already familiar with the concept of a code smell, this was first introduced, I believe it was by Martin Fowler, in the book of Refactoring, where basically you look at a block of code and you go, there's something that's not quite right here. And you might not be able to identify what it is, and there might not be anything wrong with it, but it's a smell. Basically, like you grab that carton of milk, you give it a sniff, see whether or not it's any good, and then of course, invariably, boy, this doesn't smell right. Here, taste this. With code smells, what I want to do is I want to teach my developers what to be on the lookout for. So for example, if my developer is going to be working with a database, fantastic. You know what that's a perfect opportunity to do? Call a professional. Talk to your security team and go, hey, this is what I'm about to do. Is there anything that I need to be aware of? So I'm not trying to make them an expert per se in every potential vulnerability, but what I am trying to do is make them aware of these are the most common areas for pitfall. So that way now they can raise their hand and they can ask for help at that point. Number two, again, inline upskilling. Show developers on their code where the problems are and how to best avoid them. So when my developer checks in a block of code that is insecure and we detect that, hey, this is insecure, let's use this as a teaching moment. And on top of that, let's turn that into documentation. So that way this can be a teaching moment for everybody involved. So that way, when my developer, again, going back to our code smells, goes, hey, wait a minute, this sounds like something somebody else ran into, that they can go search through the documentation and they can discover where things have gone wrong. And you'll notice through all of this that we're really talking about teamwork, that we're really talking about getting our developers talking to our security team and getting our security team talking to our developers. Now, chances are you've probably attended a session in the last couple of days talking about this little thing called generative AI. No, never heard of it? Oh, okay. Well, anyway, there's this thing called generative AI. Surprise. So let's talk about the role that Gen AI is going to play in secure code. Now, I was really hoping for a bigger laugh on that. The first big place where generative AI can help our developers is in helping to identify whether or not code is insecure. It's wonderful to be able to go to a block of code, highlight it, and then go to my chat window and go, hey, are there any vulnerabilities in this code? And get that answer right there again on my code base. And one great part about this is this allows me to ask that question without necessarily having to go bother somebody else. Again, remember, there are humans involved in the process. Remember, developers are humans. I know it doesn't always feel that way, but trust me on this one. Go with me on this one, okay? So if my developer can ask the Gen AI right there, hey, they're going to be far more likely to do that because now they don't feel like, oh, I've asked Judy 14 times in the last 3 days about something. I really don't want to keep bothering her. They can instead start to get some answers here, start to form some better opinions, and then if they realize, hey, now I'm really stuck, I really don't know what to do here, then they can go on, but they can get some great answers just right away through support of Gen AI. The other really big thing is that generative AI can also help in writing more secure code because it can have different filters that are built in that won't output some of the most common vulnerabilities. On top of that, Gen AI is wonderful for fixing vulnerabilities as well. Now, I mentioned at the beginning I do work for GitHub, so the couple of demo slides that you are going to see are going to be of GitHub products, but everything that I'm highlighting here, other vendors have as well. You could write it on your own as well if you want to. My role here is not to sell GitHub, but I just need a demo. So here we go. And so this is the ability to have autofix, say, on a pull request. So we can see a little GIF here that's creating a pull request. The scan is running, and then eventually it's going to realize, hey, you've got a vulnerability, and it will give me a description of what that vulnerability is about my code right here. Great learning moment. And then I've got a button, which appeared on the screen probably a bit too fast, that says, fix this. And then they hit that button and it updates the pull request. And the great part about this is that it will then rerun the security flaw, do that sentence all over again. It's going to rerun the security scan, that's better, to make sure that the updated code is in fact valid. Because if there's one rule that everybody should learn about generative AI and code is never, ever trust generative AI without putting it through your normal DevOps process. Okay, rant over. Now, what about for existing alerts? And again, the exact same thing, that we can incorporate generative AI here as well. So I've got an existing problem, and then I hit generate fix, and then allow it to fix it. Finally, last but not least, though, is What about our tech debt? And without a tool like this, I'm just going to go without this for a moment, you really are going to need to stop and create a plan for how to manage that. This was a couple of decades ago that Microsoft actually stopped all development for an entire month just to go back and update all of their insecure code. I'm not necessarily saying, hey, take an entire month, but take it seriously. Because if you don't at some point stop and do that spring cleaning, it's going to continue to fester and it's going to continue to get worse. So at some point, we are going to need to go back and clean everything up. If you get a tool, and this is the GitHubs with campaigns, that what you can do is once you've identified a particular class of vulnerability, you can allow it to then go in, find all those vulnerabilities, and again, with the magic of Gen AI, create the fixes for it. Now, here's the catch to doing all of that, and again, it holds true here with any form of autofix as well, is generative AI. We still need to have that proper DevSecOps in place. So I need to make sure that I've got unit tests, regression tests, end-to-end tests, that DevOps is still core to good DevSecOps. How about the code that we use? So 90% of apps use open source. And when we start talking about open source, things start to get a little bit tricky because I'm not just taking a dependency on one project. I'm taking a dependency on the projects that has a dependency on, and that has a dependency on, and that has a dependency on, and that has a dependency on. And on top of that, I'm also having to take the code from all the developers that are contributing to all of those packages that in turn I am now taking that dependency on. And so what can then wind up happening is I've got a vulnerability that's been introduced all the way down here, but again, I'm taking that dependency, and now I have that possibility of a vulnerability. So how do we catch this? How do we deal with this? Well, the first big thing is we do need to enable open source organizations to be able to secure their code as well. Because at the end of the day, we do need to catch all of those errors down there. Again, this is not a security or a sales pitch, but one of the big things that GitHub does, because we understand that open source is not free, is all of our security tools we make free for public repositories. So we're giving people the tools that they need to help secure all of their code. Beyond that, though, when I take the dependency, I now need something that's going to alert me anytime that I do have an insecure package. And so our product happens to be Dependabot, Veracode, everybody else has one as well. So what happens when an insecure package is detected? Well, one thing that we can do is just simply bump the version. How many developers in here have ever had a bad experience just bumping a package version? Every hand should go up. Okay, so if we are going to just simply bump the version, it's only going to be possible if we have, again, that good DevOps process, because I need to be able to detect whether or not something has gone wrong here. On top of that, though, I also need to make sure that we're taking an opportunity to potentially rewrite our code. Because again, oh yeah, we need to bump a version. I'm worried about it breaking things, so we don't. I need to bump a version, so I don't, so I don't, so I don't. And eventually, we're going to wind up in an environment where the world still runs on COBOL, and there are still thousands of Python 2 applications out there. So again, we need to take this seriously. We need to make sure that we are taking that time to bump the versions. Last but not least is keys in our code. That when we think about security, we're generally thinking about that vulnerability that's inside of our code base. What's often overlooked, though, is honestly the #1 vulnerability, and that is tokens in our code. On a monthly basis, how many times do you think an AWS credential is written to a public repo? Take a guess. Thousands? It's actually only, he says, 7,000. Just 7,000. And that's only AWS credentials. That's not counting any other type. That's only AWS credentials, and that's 7,000 a month that's written out to public repos. So one of the things that you can do is you could create a script or like a pre-commit script or a pre-push script that's going to look for any credentials in your code based on maybe like a regular expression and then block that from being pushed up. Because the problem that you're going to run into, I'm just going to skip over to here real quick, is once the key is inside of your Git repository, because Git is wonderful at maintaining a history. That's its job. It's terrible at giving you an ability to get it out of the history. So the moment that it's there, you need to make sure that you have that plan in place to mitigate that. What's your plan for rotating your key? What's your plan for removing the key? And I also want to highlight real quick here that when we enabled push protection blocks, that you'll notice on public repositories that thousands per month we are blocking. So people are constantly trying to connect or to check in keys. But again, I want to talk about this human aspect here on key management. The #1 reason that a developer is going to check a key into the code base is because they're going, I just need this to work. I'll go back and I'll clean this up later. So they just put in the key and away they go from there. It might be because they're reading it from documentation, because sadly a lot of documentation will have you basically create a header portion of the file and just put all of your keys up there. There is a reason that they do that. I was actually talking to a docs team once, and I still don't agree with it, but in any event, there we are. But the #1 reason that they're going to wind up doing it is because, again, it's like, I just need this to work. I'll go back and I'll fix it later. And again, later never comes. Or they push it out and it's already too late. And in fact, there's a really famous story about EA that somebody checked in a credential for internal. And somebody was able to then use that credential with a little bit of social engineering and be able to demonstrate, hey, I'm actually part of the team, and gained access to the source code for the engine for the sports games that EA publishes. So keys matter, keys matter. So if that's what my developer is doing, the #1 thing I want to ask is, okay, well, how easy am I making it for my developers to do the right thing? That whatever your key management is, make sure that it's very easy for your developers to use, make sure that they are well trained on it. So where then do we go from here? #1, again, use the right tools. Make sure that you are using tools that your developers feel comfortable with. Make sure that you're using tools that are automated, that are seamless. Play to people's strengths. Developers are developers, security professionals are security professionals. Let them do their things and also let them talk to one another. And if there's nothing else that you picked up from all of this, is that, again, we are all humans. We're all under a lot of stress. We're all under a lot of pressure. Let's have empathy with one another. Questions? Oh, thank you.